Hi, this is September 20th meeting to talk about extensions for JupyterLab. I'm going to give an overview of where we're at now and walk through the documentation. And okay, just to verify, can everyone still see my Chrome window? Thanks, Dan. So what we're looking at here is a documentation for the extension builder. This right now is the entry point for someone who wants to build an extension for JupyterLab. We will eventually have a cookie cutter that automates some of this, and you just fire that thing up and you're ready to roll, but we're not quite at that point yet. So we'll start here at the documentation for the extension builder repo that's in Jupyter. So what this repo provides is both the way to generate the build artifacts for a plugin, as well as the way we are consuming said plugin. So it's all in one place. So you can see the code together side by side. Both the loader and the builder exist in the same library. So what it comes down to for an extension author is they're going to use a script that we provide called build extension. That takes a set of options, and you give it an entry point, which is a JavaScript file in CommonJS format, so module.exports style format, that where the default export is a Phosphor plugin that is tailored to a JupyterLab shell, a JupyterLab application that has a JupyterLab shell in it. So if you look at my example here, module.exports is just an iPlugin interface where at a minimum it needs an ID, which is a name, and an activate function that takes the actual JupyterLab application. Here I'm just showing that we have access to the command registry in the application, and we can require other plugins here. We can provide an interface, and we can add things to the shell here. I mean, the world's your oyster. This is just the entry point. And this particular extension only provides one entry point, but this can be an array of plugins that you're providing as your third-party extension. So it can either be a single object or an array of objects, but it's preferred to be an array as a type, but we can accept a singular object. So the author would create their extension, and then at their entry point file would have this type of export of their plugin that consumes a logic that may be in other files, but this is just a way to get into that logic. So this is just the iPlugin object itself. And then when they're ready to build, they use the build extension script that we provide. So this is just a JavaScript file. And again, this would be templated as part of a cookie cutter. So they wouldn't have to just necessarily start writing a node file themselves. It's both the sample file and a more simple script to run it will be provided as part of the cookie cutter.
Can the activation return a promise for people simple? Is there like some assumption about what it is?
The activate function. This will actually be a link to what an iPlugin is in Phosphor, and I can bring that up in a separate window. But the activate function returns either a promise or a value, and in this case, we haven't said that we provide an interface. So what this is expected to return is either void or promise of void, because we haven't declared that we provide an interface, an object type. But that's a separate discussion. But yes, there needs to be a link that takes you to what a Phosphor plugin is here to close that loop. So at a basic level, what we need to provide to the extension builder is the name of the plugin, the path, the relative or absolute path to the entry point file that exports the plugin objects, and an output directory where the build artifact should go. So if you run this script as using Node to run the JavaScript file, the output at the very least will have two files in that build directory. It'll have the name of the extension JavaScript, which is the main bundle, and then a manifest file that describes the bundle. The manifest file is an implementation detail that the server uses in order to figure out what the from the build artifacts, where are my entry point bundles, and within those bundles, where is the entry point module. So the extension author doesn't need to know anything about the interface, but we will document that, basically ABI. That doesn't exist yet. So we'll keep going here. Once they've built the artifacts, they will ship them either as a Python package that's wrapped in the way we distribute notebook extensions generally these days is in a Python package that contains JavaScript artifacts, or it could be just an npm package that it gets installed without using the Python mechanism. But either way, it still goes through this JupyterLab extension, which actually right now exists in JupyterLab itself. So it's JupyterLab. I'll bring that up, so at least we know what we're talking about. And again, there'll be a link to that with documentation that should exist here. So Lab Extensions is part of the JupyterLab Python package, and that provides the command line script to both install and enable, disable, and uninstall lab extensions. That it moves the build file artifacts to a known location. So some Jupyter path / lab extensions, and then the name of the plugin. That folder will contain the build artifacts, of which there will be at least the main entry point and its manifest, along with any other files that are produced by the build.
How is installation actually separate?
Yes, so it follows the same pattern as notebook extensions. Right now, no. It's just following the exact same patterns and defaults. Yes, it's very much a copy and paste of both the code and the default behaviors of the lab extension right now.
We're hoping that someone will implement a conf D approach and will happily move over to it.
So yes, we're waiting on Sylvan.
So we had a discussion about this just before we came.
Okay.
It's up and, yeah.
Okay. So yes, this will be changing the semantics of the lab extension, definitely for the better. So that's still a work in progress. But for right now, you can use this lab extension command. So if I'm not sharing that particular screen, so I won't go there. But from the command line, you can type Jupyter Lab Extension -H, and it'll give you the options there. So it's very much like the existing notebook extension mechanism. So going a bit deeper in terms of what's going on under the hood, we are using Webpack to generate the bundles, but we modify the modules created by Webpack to use our custom module registration and loading mechanisms. So we use, similar to require.js, we have our own define function, except our define includes the fully qualified package name, version, exact version that we're using of the module, and then the full path to the module. So it's very explicit which module we're talking about here. And then when we the require functions, so the Webpack will stamp in a module ID when you require, so it's just a number. We're replacing that number with a Semver mangled fully qualified path to what was actually being required. So in this case, we wanted something from the Phosphor library. Our package.json said that we wanted a Phosphor that's minor version 6 or anywhere in that minor version, and this particular path. So anything 6.1 through 6.69 would fulfill this require statement. And what this allows us to do, because we're using a Semver range versus an exact fully qualified path, is that we can do client-side deduplication of modules, meaning that if we have both Phosphor 0.6 tab panel and 6.1, we can just choose the 6.1 because it maximally meets the Semver requirement. And what that enables us to do is, to the best of our ability, only have one version of each module on the page, which allows us to the two benefits of that are you can use instance of, because it's the same class or prototype that you've instantiated, which is a mechanism, for instance, that Foster uses to enable drag drop across different containers. It checks to see if it's an instance of a widget before allowing you to actually drop into a doc panel. Another thing that a reason you might want deduplication is if you have module private state. For example, in Jupyter.js services, we are storing a list of currently running client-side kernels, and that enables you, if you want to use that same kernel, you were not creating another WebSocket on the same socket. You just get that same you get that same kernel back. So there's two reasons to do deduplication. Period. Now, because Webpack modules are expected to be synchronous, in that it's taking common JS code and making it available on the web, means that require calls have to be synchronous. So if you require a module, it's expected that module has already been defined and loaded on the page, which means that you must have loaded the bundle containing that defined module. And so we have an entry point called ensure bundle. So that can be used to dynamically load these bundles on the page and then be able to require modules within them. And so this is a mechanism that could be used later for a dynamic plugin loader to load bundles after the fact. But as of right now, we are not actually using that mechanism because the server is looking at which lab extensions have been enabled and installed, and is actually just adding those as script tags to the page that it's templating to serve the lab extension, the /lab entry point handler. The build extension function, we've only given the default options here. By default, we are providing some Webpack configuration for the end user. We are extracting all CSS into a separate file. So if any of the code used by this extension had CSS in it, a myCoolExtension.css file would be created that has all of that, and that's using the extract text Webpack plugin under the covers. We also, by default, provide all of the loaders that are used by JupyterLab itself. So that includes JSON, HTML, some image formats. So most extensions that don't have exotic file file types that they're importing can probably just use these default options and be fine. Now, for example, BQplot has less files that it's using, so it would need to provide extra configuration here in the form of a Webpack loader for less files. So that would just be an extra argument to the build extension file. Now, if you did not agree with the fact that we want to handle all CSS for you, then let me go to the code there. So builder, and I'm going to go down to the options. So there's a flag to disable the fact that we are extracting CSS for you. So that turns off our internal use of the extract text Webpack plugin, and you can handle CSS how you like. Also, if for some reason you didn't like any of our default loaders and you said, no, I'd like to provide my own, you can disable the default loaders using this flag. And then any additional Webpack configuration that you'd like, including your own loaders that either augment or replace our default loaders, or any other valid Webpack configuration, could be given. So this is an escape hatch to inject more Webpack configuration into the build. And that is using the Webpack config library to merge, to intelligently merge those Webpack configs for us. And as an extreme fallback where you need completely custom control over the entire build process, you can just directly use the JupyterLab plugin and have your own Webpack config file. So here we're Where is it? Here we're just using that Webpack, the JupyterLab plugin in our default Webpack config. So in the absolute advanced case, all they would have to do is use our JupyterLab plugin to, at the last stage, after all assets have been emitted by Webpack, convert those modules into our module format. So it should work, and we can cross that bridge if we get there. If there were some case where the JupyterLab plugin couldn't handle some exotic set of other plugins that might interfere with its ability to parse those modules, but I don't think we would get there. I'm going to go back to the README. Okay, so then, yeah, I talked about injecting your own Webpack configuration, and then the absolute fallback of just using our plugin to do that mangling. Now, the use of BQ-plot brought up a point where other containers might want to use this same kind of version mangled both defining of a module and the consumption of a module. So it looks like we might have a registry on Jupyter.js widgets that uses some of the functionality of this library to enable its own container where things can be registered by name and looked up by Semver. So not at the global package loader level, but make these components available for use in other contexts.
I just add one small thing. If you scroll up right there, the build extension, the entry key is not necessarily a file name. It's actually a module. So it's whatever you'd write in a require statement that exports the plugin definitions above. So you can do /index.js, but it uses the node module resolution framework. So that could be /index. It's just going to use the
right.
node
So
module resolution.
This is the entry path for a Webpack config. So it has the same semantics as that.
Right. It's the entry point for the Webpack config, and there that's a module, not a file path.
Right, and this could actually be an array of modules where the last one is actually the entry point. So all the standard Webpack rules apply here.
Yeah, I guess I should say it's interpreted as a module that you would put inside a require. So clearly it is a path, right, but it's being interpreted as a module. So it doesn't have to be a full path.
If you've written your extension in TypeScript, do you compile it first before you run the script?
Yes, the build script ingests CommonJS.
Yeah, in which case, what you do is the default export of your module is what's picked up there. So make a module that has a default export, which is your plugin definition.
Yeah.
And that module will be in your entry. And there you wouldn't necessarily do .js. You could just do /index,
right,
and it'll pick up the JS. And you won't have to.
I'm a bit confused by the syntax when you require these instances. So you scroll down. When you require an extension, require phosphor /lib/ui/data. What we would do in node context would be to require phosphor, then do dot.
No, this is a fully qualified path to the module. Phosphor doesn't have an entry point.
Okay.
So if you take out the at part, that's
what you would normally
require. Node.
Yes.
Yeah.
Oh, that's also.
So all we've done is insert the at.
So phosphor has multiple bundles.
There are no bundles. Phosphor is just a set of modules that you can import a la carte.
Okay.
And JupyterLab is the same way. It's an a la carte set of modules.
Okay, so it's very different from the widgets library that we've done that have a single entry point.
That's right.
Which is going to be in JS.
Yeah, in which case you could do require widgets at blah blah blah, close quote, close parentheses, dot, whatever.
Yeah.
Okay. Questions from the crowd? I was going to say crowd.
Do we have a template, a plugin template that has all that?
We don't have a cookie cutter yet, but we do have the simple example he did. We have widgets.
Okay, so those.
Which has an extension and a beginning PR and BQ plot.
But I can try to compare across, which
Yeah.
shouldn't be.
And really, we want to take the IPy leaflet plugin that's sort of not core and to JupyterLab, and we can turn that into a very, very simple plugin.
But it's not IPy, it's just the
it's the leaflet, the leaflet file renderer,
Leaflet.
the GeoJSON file renderer. We can turn that into a separate plugin.
And this is just naming conventions.
Yeah. Do you want to go to the IPy widgets repo, and you can see how it works inside of a Python package? So if you go to the IPy widgets,
So do you think we would ship that lab extension?
go down to the widgets lab extension. Yeah. So here you can see
it could be used separately from IPy leaflet.
So look in package JSON.
I don't think it's the same thing.
It's very different.
That would benefit from the deduping.
So we benefit from
Deduping of
yes.
So here it is in IPy. Oh, go ahead. Sorry.
One thing that we could do though is have a viewer for widget manager states that is completely independent of the back, like we do for embedding into static web page. And
save states to JSON.
so since we already have it and it works in static web pages, we should make a viewer for this.
Yeah, .ipy widget.json file.
Yeah.
Oh, yeah.
So I was thinking of like one of the things we would have to do, like
We're gonna need longer days.
Someone's a good clone. He gets more work done than you do. That's a good clone. So here's just a brief overview of how it works in IPy widgets with the Python package. So here's the package JSON. So like most of our sort of JupyterLab extensions, this is a Python package as well as an NPM package. So the NPM package, you see the build. Essentially what it's doing is it's calling this scripts build extension. So the build builds the source, compiles TypeScript to JavaScript, and then it runs the build extension, which just runs this one file right here. So that file is the very, 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 very simple file, thanks to all the work done behind the scenes by Steve, that just calls this build extension script. It gives it a name. Here's my entry point, and notice here again, I'm referring to the compile JavaScript. It's in the lib directory, and I don't worry about .js or anything. I mean, Node will pick that up in its resolution. And my output directory is in my Python package static directory. So I'm taking it from my lib directory, bundling it, and putting it in my Python package static directory. I'll let that sink in for a minute.
And then did we go to the
yeah, so again, TypeScript gets compiled to the lib, and the bundling takes the lib JavaScript files, bundles, and then puts it in the Python static directory. Okay, so now here is my Python package that setup.py bundles up into a PyPI package. And when I run it, there will be an extra static directory in here, and that will include all the bundled resources. And the init.py has the one little bit of magic to be able to install a JupyterLab extension, which is exactly mirrors the notebook extensions, which is the name that it'll copy it into the share Jupyter share lab extensions directory, and the source is the static directory that's generated in here from that build extension script.
How do you declare? So I guess you declare npm dependencies just like the normal.
Yep, and those get bundled in.
And they get bundled in.
That's right. Bundled in and then deduped at runtime.
Right now, the only deduping happens at the on the client side.
Right.
So we may. I don't think we'll ever dedupe.
I mean, there is deduping when you compile npm with local packages. Like if two of your dependencies require the same package.
The deduping we're doing is on the client right now.
Right.
I don't think we'll ever do it at the build stage, but it could very well be the server can do some client server side support.
So do we have the ability to manually configure?
Wait, can you guys hear Brian? Brian's questions? Is that coming out on the recording?
A little bit, not great.
I have no problem.
do we have the ability to manually specify that a dependency shouldn't be bundled? Like, if I know that D3 is already on the page.
No,
Okay.
not right now. We had talked about doing stuff like that, maybe as a second cut, or automatically saying things that I depend on that happen to be JupyterLab plugins don't include dependencies that they have.
The
But
only explicit
problem-
script tag on the page is MathJax.
Yeah.
Everything else is contained. So nothing else should exist on Windows except for Jupyter, which has things like the define function require, ensure bundle, version number, and the application itself.
And I
Right,
guess
but if
I'm
you
wondering
know
about-
that one of your dependencies already put D3 in the package cache, that's okay.
And
Right.
I'm wondering about things like phosphor itself.
Yeah, it'll be bundled by everybody.
Bundled by everybody.
Only the modules you use. would be
Oh,
bundled.
exactly.
Yeah.
Okay. And then can we look at I want to understand the declaration of dependencies on Python website. Can we look at the package JSON for bqplot
Okay.
and for and it's setup.py. Like I want to see what if package A or if plugin A wants to rely, or if lab extension A wants to rely on lab extension B, depend on it. What does that look like?
Okay, so we have to go to a PR. It hasn't been merged yet.
And so I'm just going to jump in there. Like, again, a lot of the things that we're seeing are a direct outcome of our hard requirement to not require the user's computer to have Node installed, like the person that's installing these extension packages. And so we don't have the option of deduping when they install extensions, because we can't expect them to have Node. But the way that we've set things up is that we can, at some point in the future, start deduping things from the Python process, because we're tagging this assembled bundle with the version information of the things that are being bundled. So since every extension is going to bundle Phosphor just because they're going to be using it, we can then go in and do a trivial dedupe stage from Python on the final bundle that's served as the JupyterLab application, which rips out things that are of identical versions. And so while it does seem like, we're needlessly including Phosphor in all of these bundles, that's a direct outcome of not requiring the user's machine to have Node installed, basically.
Yeah.
The end.
And I'll add, right, the way we're tagging the bundle files means that you don't have to write a JavaScript parser in order to strip out code. Like, we have beginning and end tags, so that it's very easy to strip out parts of the file.
And the manifest helps with that as well.
Right.
It has all the interdependencies of the requirements.
So, Brian, you wanted to look at bqplot. Here's bqplot. There's a lot of hacks right here, right now in bqplot. But what did you want to look at?
The package.json and the setup.
Okay, the package JSON. So these are the changes I needed to make to get it very hackily working in JupyterLab. So I now dev dependency on JupyterLab extension builder, and a dependency on JupyterLab, and Jupyter.js widgets. I just needed to update the version. And then what was the other one that you wanted to see?
So why does it not depend on the lab extension?
Why does what? Oh, why does it not depend on the IPyWidgets lab extension?
Yes.
Because that's what. Okay, so it will depend on that in the setup.py, which I guess isn't here right now. I need to put that in. So the setup.py will depend on the Python lab extension package.
Okay.
Does that make sense?
And then the obvious, and I guess what I'm trying to understand is there's a little bit of awkwardness in that the JavaScript code in bqplot can import code from the widgets lab extension.
No,
Not the extension itself, widgets library.
so there's the Jupyter.js widgets library, which is totally independent of JupyterLab, and then there's the widgets lab extension that adapts the Jupyter.js widgets library to work inside, provides the plugin infrastructure to work inside of JupyterLab.
Mm-hmm.
We don't touch the lab plugin for Jupyter JS widgets.
In terms of you don't use it from a code perspective.
Right. We
But
just
you
use
need
the
to do-
underlying library We do need it to be there because that's what will call us.
Oh, okay, but it calls you rather than you calling.
Yeah.
Okay, got it.
Yep.
There's an inversion calling.
Now, well, yeah. In the next iteration of this, we will depend on it. This is what Steve was talking about a little bit earlier. Right now, the hack that we're doing to get BQplot to work is that we're letting IPyWidgets call anybody, including BQplot anything, instead of having an explicit registry of IPyWidgets. So the next version will have us importing the widgets lab extension and adding BQplot to the plugin registry.
It will require something provided by the widgets lab extension to register itself as a widget.
That's right. And which means it'll have to import that in the JavaScript file, which means it'll end up in this dependency list now. So in the future, it'll be like that. Is that too confusing?
I think I got it.
Okay. Other questions? This has been working out really well. Yeah, I think I think this is a good thing to actually follow through with instead of backtrack again. Like we've been doing a lot.
I mean, it seems I'll just play with it and get all their stuff working, and we'll be happy. Should we? So minimally, we should pull the leaflet stuff out.
Yeah, I think next steps are a cookie cutter, which will help us formalize this sort of documentation and what needs to be done and what's a minimal required. And then we'd like to, I need to talk to you, Steve, we put our heads together about a generic container that lets you do this versioning magic. Right now, IPyWidgets, I hacked it to just generically load stuff from the page using the global level container. That doesn't feel very clean at all because it means every widget essentially has full gamut, just load something onto the page. Instead, I think it'd be better to have a container that is version aware, that you register explicitly the widgets that you want to be available.
So the one thing I get here is other extensions can do this.
Other extensions can
load anything.
Well,
and why would we import anything?
Yeah, why would we restrict?
Well, right now we don't.
Libraries
right now we don't officially support this dynamic require. It works. We had to have the function. It's not part of the. We're seeing how far we can get without officially supporting this dynamic require. I think it's fine to say for widgets. If you know your widget, then register yourself, and then the widget part of JupyterLab is sort of self-contained instead of.
You're trying. What you want to do now is prevent widgets from loading other things that are defined in the page.
I want to make sure that when we load widgets, we're actually narrowing our scope down to stuff that people explicitly said this is for the widgets to load.
So phosphor is included into this?
It's included in BQplot's bundle. So BQplot can still use phosphor. It's just a matter of what is the widget register. The widget itself, how does it register with JupyterJS widgets, and how does JupyterJS widgets in turn look that up? That's the part you're talking. Yeah. So just at that level, that connection.
So another step would be,
in what you said, I understood that part. But what you said, you also mentioned that you wanted to avoid Jupyter a custom widget libraries.
Dynamically requiring something by string. That's what we're trying to avoid. Right?
We're trying to avoid the Python package saying load as a widget this random string that we're going to assume is in the environment somewhere.
But you're okay with the widget JavaScript. Okay.
Oh, yeah.
Loading
I'm not saying anything about the widget JavaScript, and that'll be bundled and all this kind of stuff. I'm just talking about the main entry point for a widget, a COM target.
What is an OK entry point for
what is an OK COM target? Yeah. Okay. So that, I think, having a generic container that basically stores a name, a version number, and something to return, and then that does this deduping stuff is a nice generalization of what we have now. It may actually be a lot easier than I thought it was. It looks like it might be.
There.
Yeah. Well, maybe that you already have a class that does it. I don't know.
Yeah, but it's a class, and that's why.
Yeah.
Class.
Right.
So you can use another context.
Yeah. Perfect. Okay. So maybe just using it. Maybe there's no customization needed at all. That's what I wanted to talk to you about. Sure. So I think that's another next step. Any other questions?
I think it's great. I'm guessing that you and I want to have some lab extensions running in our talk next week.
Yeah.
I should clarify. You, I, and Sylvan.
Yes.
would want this in our talk.
Yes. I can't wait to see what lab extension Sylvan's going to write for his 15 minutes of what's new since sci-fi. I want to see your VR glasses. I want to see your gaming controller.
Do we want to do a?
No, but if we could write a lab extension that has like a Hadoop, I mean, this is Strata. If we had a Hadoop controller or an Azure controller, I mean, if there's something simple that we can do. Like an iframe on the right-hand side that lets you launch clusters. I don't know. I'm just brainstorming here. But yeah, we should. I think this is one of the main things that's new since sci-fi is a good story for how to do third-party extensions.
I can do the Altair one.
Yeah.
I already have code.
I can do the GeoJSON one.
Okay. Do we want to put these? Do we want? I mean, normally I would put the Altair one aside. Do we want to put some of these on the Jupyter org for now as like canonical? Like here's the examples that were
maybe a JupyterLab organization.
Yeah, or maybe what we can do is bundle some of them together in a single extra file readers, just so that we aren't dealing with 5, 6, 10 repos.
Well, but
for now,
then it breaks the patterns of having the Python module. And
I mean, a Python module can provide more than one plugin. Yeah. You can provide an array of plugins.
I think this maps to Jupyter Hub the way it's now its own organization.
I do.
Okay. Do you want to have a separate JupyterLab? The thing is we tried to get away from. There's a lot of friction having a separate repo. There's extra testing.
But these are independent, not interdependent necessarily.
I know.
Yeah.
I know.
Leaflet
I was
doesn't depend on anything else except JupyterLab. So.
Yeah, I agree. They really are independent. I'm just trying to think developer time and things like that. Just is it less friction to combine them for now? That's true, because then all the testing, all the infrastructure is set up.
Yeah, I do think it would be good to have each extension we sort of provide as separate components. It makes it.
We'll claim the JupyterLab dash namespace on PyPI.
I think we already promote 2 extensions such widgets on the Jupyter website, and or 4 actually are on the trying to have them live where they live. Right?
Yeah, but I mean, okay. I mean, so like, what orgs would you put Altair and
Driven?
So wait, are there any other questions about the extension building stuff? And then we can turn off the recording and we can continue the discussion and everything. But this will limit the recording for people that just wanted to hear about how to build an extension. Any other questions about building an extension or the extension mechanism? Okay. Goodbye, Internet.